Okay, so take note in Sec 3, you're aware of this relationship for Trigo. So as and when we need it, take note we may need to do the conversion. Why? Because we can only differentiate Trigo terms based on sine, cosine, and tangent. If we get any other form, we need to do the necessary conversion. Okay, so take note, these are the only three we can differentiate. When you differentiate a sine x, you will get cosine x. When you differentiate a cosine, you will get a negative sine. Last but not least, when you differentiate a tangent, you will get a secant square. Okay, let me try the most elementary question. 1 part A. Alright, 3 tangent x minus 2 cosine x. Let me label y over here first. Alright, so if 1a, I will need to do differentiation. It will be dy dx. Tangent x, when we differentiate tangent x, what will we get? Secant square. But there's a 3 in front, just write the 3 in front. Similarly, when we differentiate sine x, what will we get? Negative or positive? Positive cosine x, right? So I'll write down a cosine x. But what do we write in front? Negative 2. Then we are done already. So no need to be worried with the number. Okay, so what we need to do is just to take note of the trigo term that we are differentiating. Okay, so for part B, like we agree, we will use product rule. So what does product rule say? Differentiate the first. So I differentiate the first bracket term, do normal differentiation, bring down the power. Reduce the power by 1. Keep the second. Plus, now I differentiate the second term. Differentiate sine, we will get cosine x. And keep the first. But I don't want to write the numbers and the term behind, so I just write in front. Okay, this is the answer you get. Okay, so I want to apply quotient rule to part C because there's a fraction there. Differentiate the top, keep the bottom, minus differentiate the bottom, keep the top over the bottom square. So if I apply the quotient rule correctly, I don't have to do the necessary simplification on top because there are no like terms. So this is my final answer. Okay, now moving on to D. So part D is a function, f prime x. Use a composite function. Bring down the power. Then I copy everything. Reduce the power by 1. Then I differentiate all the terms inside the round bracket. If I differentiate 3x, I will get 3. If I differentiate 5 cosine x slowly, cosine x, when I differentiate, I will get a negative sign. Then what's the number in front? 5. Okay, again, do you think I need to expand? No need, there's a stupid power 5 binomial. You expand your 6th term, make it very messy. No need. This is already factorized form. This is already very good. Okay, for question 2, fx is given. I need to perform the first derivative to become of the form stated in the question. So let me use my quotient rule first. Using the quotient rule, not difficult. But the thing is, how to make sure it looks like the one over here? Okay, listed in the question, there are 2 terms. So this is what I see. A lot of y'all say, teacher, very simple. Split into 2 fractions. So let me do that now. So if I look at the fraction on the left, I can reduce to lowest term. This is a 1. This will just be a power 1. I will just get a tangent x at the denominator. And 1 over tangent x, just nice. Cotangent x. When this fraction looks very complicated, don't worry. Change everything to sine and cosine and we can simplify it. So, I would like to express everything in terms of sine and cosine. Then I do some simple manipulation. So the numerator, you can see I express in terms of the blue portion. The denominator is in terms of the green portion. So remember, I don't want to do division. I want to change. So keep, change, flip. So I'm going to do that in my next step. Take note, this is a x over 1. Numerator times numerator, denominator times denominator. So I rewrite everything, but I change the sign to multiply. Is there something I can simplify? Yes. Cosine square and cosine square can simplify to number 1. So what do I have? Let me write out x bracket 1 over sine square x. But I don't want 1 over sine square. The question clearly say I want a cosecant square. So very simple. You know that 1 over sine x is 1 over is actually cosecant. So let me change the form. And then we are done now. Once we change the form, we realize both your a and b are actually just 1 and -1 respectively.